Hi, hello everyone. मेरा प्यारा बच्चा लोग, good afternoon, right? Usually I have this habit of telling good evening. So right now it's only 2 o'clock. So anyway, good afternoon everyone. Jaldi tell me how are you all doing? So बढ़िया. Okay, before I check into the chat box and wish you big hi to every one of you, let's see what we are going to do in today's session. Right, in today's session we'll be doing the second part of our chapter of atoms. Matlab, we'll be completing this particular topic in today's class. Wow. Okay, this particular chapter of atoms we are going to complete in 2 classes. A class already ho gaya, and this is our second class, and we are going to complete this particular chapter of atoms in today's class by completing all the theory and with lot many numerical questions. Okay, I hope you all are ready for the same, because I came with full of preparations with water, food and whatever I need, and I hope you are also here with full of preparations. Okay, so if you are seeing me for the very first time, this is Ameer, your physics educator at Unacademy, and those who love me more, they simply call me Bhaiya. Now let's see, before we get started, who all are here and how much interested and excited you all are here for the session. Ritu, fine. Parahal. Okay, then others, tell me how you all doing. Is everything fine? Is everything awesome? Is everything going so good? Yes? Okay, so I think everything is so good, and you all are here to learn this topic of modern physics from today's class, right? Okay. Now, bacha look, if you are seeing me for the very first time, a bit of introduction about myself. I hope you all can see it on the screen. I am a BTech graduate from NIT Calicut in mechanical engineering. Fine, and I have an experience of more than 3.5 years in the field of teaching JEE, NEET and board students. And here I am. More about me you will come to know as we proceed with the sessions. Now, if you don't want to miss any of the updates about the classes that is happening in our YouTube channel, you all can be a part of the Telegram channel. The link is given here and in the description box. Moving on, Bugs Bounty, what it is? And it's an amazing program which can help you to get a lot many prizes. What do you have to do? You just have to go to the description box. There you'll find a form. Fill the form if you're finding any inappropriate content in the videos uploaded by Unacademy. If it's valid, bahut sare prizes mil jayega. Now, those who haven't, share the class to all your friends and ask them to join. This is your time. You all can share it as soon as possible right now and ask them to join the class now, because tell them that Bhaiya has already started the second and the last lecture for atoms here. Fine. Okay. Now, chalo, we have 2 kinds of subscription, which is the plus subscription and the other one is iconic. In a plus subscription, you will be able to access to all the live classes, weekly text will be happening, structured courses, and unlimited access will be there. And an iconic subscription, you will be given a personal mentor or a guidance to help you with the academic activities planning. Okay. Then other than that, expert guidelines, study material, test analysis, so many amazing things you can obtain once you are a part of this iconic subscription. If you go for 12 months of plus subscription, it will cost you 1,250, and I know that you would love to have 10% of discount. The code is AMB10. Now, if you go for iconic subscription for 12 months, it will cost you 2,333 per month. And again, 10% discount you all can enjoy if you use a code of AMB10, right? Okay, so mega offer is going on, mera bachcha log. If you go for 12 months or more than 12 months of subscription, extra 2 months will be given. Wow, wow, wow. Okay. Now, if you have any queries related to Unacademy or the batches or anything, right, you can, your counselor is just a call away. The number is what you can see there, right? And while you call, don't forget to tell the code of AMB10. Fine, cool. Okay, open house happens every time. You all can be a part of it and interact with your educators. Okay, now shall we get started? Tell me, aap sab log ready hai kya? If you all are super ready, we can get started with the session right away right now. Ready? Study? Then let's go. Right, give me at least a go here in the chat box. Tell that, हाँ sir, bilkul, just go for it. I'll just rush for it. Are you all gonna give me that? Yes? Shweta, Kunal, Atit, Ritu, right? Ready, bilkul. Okay. So tell me what we have already completed from the chapter of atoms. We already have completed the Rutherford's alpha particle scattering experiment, wo to ho gaya. And based on that particular experiment, he proposed a model, a planetary model for the atom, that is also being discussed, right? All the concepts and every theory is related to Rutherford's atomic model is being discussed. So what we are going to learn in this particular topic? The first topic of our today's discussion is going to be to find out, right, what are the drawbacks of Rutherford's atomic model. Kya hai? Drawbacks. Everyone write the heading Turant se Turant. Very important. What it is? It is the drawbacks of Rutherford's atomic model. Rutherford's atomic model. Now we all know that Rutherford actually compared the planetary model of okay, or the solar system model to the atomic model, right? Just like there we have a sun and the planets revolving around the sun, he just made the same comparison to the structure of the atom, where he told that we'll be having the nucleus exactly at the center and electrons will be revolving around it in circular orbits like this around the nucleus, right? Just like the planetary model, he proposed a model for the atom, right? Okay, sab sahi tha, everything was good there, but only problem, okay, the only drawback in this Rutherford's atomic model was that, right, he forgot there is a slight difference that can happen between the planetary model and the Rutherford's model. Kya hai wo? Arey, these planets are completely neutral. Even though the planets are revolving around the sun, they are considered to be neutral, but that is not the case in the atomic model of Rutherford. Because here it is the electrons which are having the negatively charged, okay, it is revolving around, it is moving in circular orbit. If any particle move in circular orbits, right, or in circular paths, what will be there? Centripetal acceleration will be there, or in general an acceleration will be there, right? Ho jayega kya? Yes, there will be an acceleration. If a charged particle accelerate, we know that what will be produced? If charged particle accelerate, electromagnetic waves will be emitted out. Matlab, as the negatively charged electrons keep on moving in that circular orbit, it accelerate, it will be giving out electromagnetic radiation or electromagnetic energy. Matlab, as the electrons keep on revolving, it will be losing energy from it. Okay, array, obviously it will be associated with kinetic energy also because it is moving. So if it loses energy ka matlab hi hai, okay, it is losing its kinetic energy, speed to decrease ho jayega. If speed of this electron keeps on decreasing, what happened? Array, this electron will be spiraling towards the nucleus and finally it will be falling into the nucleus. But this is not happening. So this is one drawback of Rutherford's atomic model, because if we have followed Rutherford's atomic model, these electrons should be falling into the nucleus, which is not happening. Okay, this is not happening. So understood, this is one of the drawbacks, or this was one of the mistake with which Rutherford couldn't identify when he proposed this particular model. ये तो सही है, समझ में आ गया? Hi Myara, Mayank. So understood the first drawback of Rutherford's atomic model. Okay, so I will write it here. If charged particle accelerate, right, it should emit electromagnetic radiation or electromagnetic energy. It will be emitting out electromagnetic energy, which means as the electrons keep on revolving around the nucleus, it will keep on losing or emitting electromagnetic energy, which means it will keep on losing its energy. Uska kinetic energy decrease ho jayega, speed to decrease ho jayega, and it will be finally spiraling into the nucleus. But this is not what is happening. Okay, so this was one of the drawbacks of Rutherford's atomic model. ठीक है? What is the next one? देख ले, if the electron is emitting out electromagnetic energy or electromagnetic radiation, initially it will be emitting out huge amount of energy because it is possessed with huge amount of energy, है ना? So initially it will be emitting out a huge amount of energy. ठीक है? Initially, I'll write it. Initially it emits huge amount of energy. Huge energy will be emitted from it. Right, and it keeps on giving out energy because it is continuously revolving around the nucleus. Right, it keeps on giving the electromagnetic energy. Right, as the energy keeps on decreasing, the amount of energy that this electromagnetic energy that will be released will also be decreasing. है ना? The amount of energy will also keep on decreasing. And energy का formula क्या है? H. So as the amount of energy released during this spiraling process decreases, the frequency associated with the emitted radiation also decreases. Okay, and it keeps on decreasing until it becomes zero. Matlab, if we collect all the frequencies that is emitted by this electron before it falls into the nucleus, we will be getting a continuous set of frequency, right? Starting from a higher value of frequency, right? We will be getting an entire set of frequency till it is zero. Yes or no? Yes or no? Right? We'll be having a frequency, let's say this frequency is 500, then we can have a frequency of 440, 499, 498. Matlab all these frequencies will be obtained till it falls into the nucleus. Yes, Neha. इधर तक समझ में आ गया ना? बिल्कुल. Okay, is there a lag? Is it clear? Can you all see me and hear me? जल्दी बता. जल्दी बता. जल्दी बता. Okay. So let's proceed further. What is atomic spectra and the concept related to atomic spectra we will discuss later. Now we will start with the Bose atomic model. Okay. Fine. Okay, let's continue. Now we just got to know that, right, Rutherford's atomic model is not the correct model for the atoms, right? It is not the correct one because we have seen some of the mistakes and some of the drawbacks in the Rutherford's atomic model that we have discussed already. So the scientists started to discuss, right, about the atomic model concepts, and it was the Niels Bohr, right, who finally came up with a new model for the atom. After rectifying all the problems with Rutherford's atomic model, it was Bohr who came up with a new model for atom, which is called as Bose atomic model. So shall we discuss each and every postulates of this Bose atomic model one by one? Are you all ready for that? Ready hai kya bhai? Chalo. theek hai. Let us go with the first postulates of Bohr, and here it goes like this. Bose's first postulate was that an electron in an atom could revolve in certain stable orbits without the emission of radiant energy. And the main problem with Rutherford's atomic model was, right, electromagnetic radiation, right, or continuous discharge of electromagnetic radiation from the electrons, right. So in order to rectify that issue, Bohr told that, right, obviously electrons are revolving around the nucleus in a circular orbit, right, circular stable orbit, but without the emission of radiant energy. He told that emission of radiant energy is not happening. ठीक है? Fine. And he also told that, right, only in specific orbits electrons are revolving around, and those specific orbits का नाम है stationary states. Okay, only in those stable circular orbits, right, electrons will be revolving around with a specific or a given value of energy. Matlab each orbit around which the electrons are revolving will be having a specific value of energy, right? Okay, and those orbits are called as stationary states. Okay, so he actually gave a name for the circular orbits, and that name is actually stationary states. Okay, what is the speciality of all these stationary states? These orbits or the stationary states will be having a specific amount of energy, and only those orbits which has a specific amount of energy, there the electrons will be revolving in it. Clear? Moving on, second postulate. Now, in the first postulate was discussed, or Bohr proposed that when electrons are revolving around the nucleus in orbits, right, it will be revolving in those orbits where there is a specific or a fixed amount of energy. Matlab, let's say this is the first orbit, right? First orbit will be having an energy of E1, right? Let's say this is the second orbit, it will be having an energy of E2. Matlab, those orbit which is having energy of E1 will be existing, that orbit having energy of E2 will be existing in that way. Clear? He told one more thing, right? Only those orbits will be existing where the angular momentum of those orbits is equal to nh by 2 pi, which is having an integral value of h by 2 pi. Matlab, if the angular momentum of the orbit is equal to h by 2 pi, if it is an integral multiple of h by 2 pi, then those orbits will be existing. So for the first orbit, what will be the value of angular momentum? N takes 1, it is h by 2 pi. For the second orbit that we have found out here, the angular momentum when electrons revolving around it will be equal to 2 times h by 2 pi. For the third, 3 times h by 2 pi, and for the nth orbit it will be n times h by 2 pi. So he told those stationary states that we have discussed, or the fixed circular orbits, right, is being decided on the basis of the angular momentum it possesses, and only those orbits will be sustaining where the angular momentum is an integral multiple of h by 2 pi. Okay? This is also very important, right? We must keep it in mind and don't ever forget it. Clear? Super clear, everyone? Awesome, clear? Okay, so moving to the third postulate. I'll explain you in this detail. Okay, तो बहुत important postulate है. देख ले. We have the nucleus here. क्या है? हमारे पास nucleus है. We have the first orbit here. है ना? पहला orbit भी है. Okay, let's say this is the दूसरा orbit, मतलब second orbit. Tell me, if I mark this as E1, energy of the first orbit, and E2 as the energy of the second orbit, which energy will be greater? बता दे. Whoever is here in this classroom, tell me. Myara and art insider, Ritu, tell me which energy will be greater. Okay, whether it is E1 energy or E2 energy. Who can tell me? किसको बता सकता है? No one? I'll explain. Now, just consider that electron is in the first orbit. When electron is in the first orbit, it is more close towards the nucleus of positive charge, and it will be more attracted towards the nucleus, because electrons have negative charge. These negatively charged electrons will be more attracted towards a positively charged nucleus. More attracted का मतलब ये है कि the electrons will be more stable, right, when it is in the lower orbits, or let's say here in this case first orbit. So when it is more stable, any body which is having more stability, it will be having less amount of energy. Matlab, those electrons close to the nucleus will be having less energy, and as we move away from the nucleus, energy increase हो जाएगा. ठीक है, energy तो बढ़ जाएगा. And do you know what is actually talked in the third postulate of Bohr? Very simple है. देख ले, an electron in the second orbit or any higher orbit with higher energy, if it moves from that higher energy orbit to lower energy orbit, what will happen? The electron is moving from higher energy orbit to lower energy orbit. matlab some energy will be released, right? And that energy will be released as photons, matlab particle nature of light, and the energy of the photon released during this electron transition will be equal to what? Yes, the difference in energy of the orbits. And if it moving from second orbit to first orbit, right, E2 minus E1, which is the difference in energy of the orbit, will be equal to the energy of the released photon. ये भी सही है, ये भी सही है. Energy photon is being released. Obviously a photon has to be released, है ना? देख ले, here electron, let's say it has some 20 joules of energy. I'm just giving the values, ठीक है? When it comes to the first, let's say it is only having 12 joules. मतलब the energy has decreased. According to conservation of energy, we know that energy can neither be created nor be destroyed. So when the electron is losing energy from 20 to 12, कितना energy lose किया? 8 joule, right? That energy lost by the electron will be given out to the surroundings as photon energy or light energy. समझ में आ गया? And this energy of the light or the photon emitted will be having a value equal to difference in energy of the orbit. ये तो बहुत सही है. Clear है? This is very important. Don't miss it. Okay, so it's very simple. When an electron moves from higher energy orbit to lower energy orbit, energy is released. Now, let me ask you, okay, though it is not a postulate of Bohr, but it is really required for understanding this topic. If an electron want to move from less energy lower orbit to high energy higher orbit, right, what should be given? Should we have to give energy? Arey bilkul. Right, if the electron with a lower energy, if it wants to move to an orbit of higher energy, we have to give energy. Energy should be given. Energy should be given. Okay, how much of energy has to be given? कितना energy देना पड़ेगा? अरे same, whatever is the difference in energy between the orbit, the same amount of energy has to be given here. उतना ही. देख ले, I'll tell you. First orbit is only having 12. The electron is in the first orbit. Second orbit ka energy level is 20. So if the electron in the first have to go to an orbit of second, or if it want to go to the second orbit, kitna energy dena padega? Already it has 12. Now if it wants to stay in the second orbit, it should be having 20. So how much energy has to be absorbed by electron, or how much has to be given to the electron? 12 plus 8 or then so that 12 plus 8 will become 20, so that the electron can be in the second orbit. Clear? Is the concept getting clear? समझ में आ रहा है? मन पे आ रहा है? हाँ सर, ठीक है. Let me close my eyes and understand that. हाँ सर, बिल्कुल. Getting the concept, understanding everything. क्लियर? कोई भी डाउट है तो पूछ ले. Okay, everything is quite clear. बिल्कुल बढ़िया. Then I think we should start solving some of the important formulas here, right? So many important formulas has to be derived. Are you all ready for the derivation? Derivation के लिए ready है? Okay. Now देख ले, in the Bose postulate, he was not just putting forward all these conceptual ideas, right? He actually found out what are the radius of each and every stationary states. मतलब what are the radius of each and every orbits around the nucleus. He did that, right? And he also was able to find out what is the speed with which electrons will be revolving in each orbit. That is also being found out, right? And he also got what are the energies of each and every orbits. But he was only able to apply all these concepts in hydrogen atoms or hydrogen like atoms. What are hydrogen like atoms? I'll explain. Okay, so he was only able to prove all the concepts on hydrogen atom and hydrogen like atoms. Okay, देख ले हाइड्रोजन एटम का स्पेशलिटी ये है कि there is one proton in the nucleus and one electron revolving around. So those atoms which has one electron revolving around the nucleus, that are called as hydrogen like atoms. I'll give you an example. Helium usually has two electrons revolving around, है ना? देख ले nucleus of helium. This is the first orbit. In the first orbit, two electrons are revolving around, ऐसे A और दो. Can we call this as an hydrogen like atoms? No, because here we have two electrons revolving around the nucleus. If we remove one of the electron, helium becomes it's helium ion, He plus. Right? So if it becomes He plus, what we are actually doing? We are removing one of the electron. So in the helium atom right now, there will only be one single electron revolving around the helium nucleus, and this is called as hydrogen like atom. आ गया समझ? आ गया as a concept लिया? What is an hydrogen like atom? Okay, so what I was telling was the Bohr was only able to experimentally prove all these concepts for hydrogen atoms or hydrogen like atoms. ठीक है? Because the application of all the postulates of Bohr to higher level atoms was not so accurate. Okay, we'll discuss the drawbacks of Bohr's model also later. But let us continue with what all more we have to learn from this Bose model. ठीक है? मिल रहा है ना सबको? म्यारा, श्वेता, कुणाल, मायंक. अरे नन्नू मुन्नू कॉन्सेप्ट है, बढ़िया बढ़िया कॉन्सेप्ट्स है. ठीक है? So just listen to it, you will understand everything, every bit of it. ठीक है? ठीक है ना? Okay. So yes, let's get started. First, let us make an equation for the speed of electrons when they are revolving in all the orbits, okay, in an hydrogen nucleus or in a hydrogen atom. For that, we should be simply needing the second postulate of Bohr, where it says angular momentum is equal to nh divided by 2 pi. What is the formula for angular momentum? Mass into speed of electron in the nth orbit into radius of electron in the nth orbit, mvr, L ka value, that is equal to nh divided by 2 pi. Okay, now for continuing further, right, we should be having a simple we have to take a small chotu concept what we already have learned from Rutherford's model. What was it? Right, it's very simple. In the case of hydrogen atom, we have one positive charge and one negative charge which is revolving around it, right? So during the circular motion, right, the centripetal force of mv square by r is being provided by who? Who provides the centripetal force when electrons are revolving in circular paths? Very simple. What is it? Yes, it is the Coulombic force of attraction between the positively charged nucleus and the negatively charged electron. Formula is 1 by 4 pi epsilon 0. Charge of proton into charge of electron, both are E into E square divided by, let's say, the radius is r square. So 1 r cancels, mv square is equal to 1 by 4 pi epsilon 0 E square by r. Cancelling r from both the sides of the equation. Okay, so mv square का वैल्यू मिल गया, ठीक है, और v का वैल्यू कितना हो जाएगा? Tell me from the above equation, v का वैल्यू कितना हो जाएगा? अरे it's very simple. देख ले, that will be root of taking this m to the right hand side of the equation as its denominator. This will be 1 by 4 pi epsilon 0 E square divided by, okay, m goes m into r. Clear? Clear? बढ़िया? बढ़िया है ना? ठीक है. Now You can again simplify this, because in the equation of speed we have radius, and radius of the orbit is also something which we don't know. So we have to substitute for mr. Kaise? 1 by 4 pi epsilon 0 e square by, what is m into r? ये तो m है, ये तो r है. So m into r is nh by 2 pi into vn, right? Yes. So mr I'm going to substitute it as nh divided by 2 pi into vn. So obviously we have a velocity on the left hand side of the equation also. ठीक है, तो क्या हो जाएगा अभी देख ले, ये vn तो ऊपर हो जाएगा और अच्छा लोग. Okay, so if this vn goes on the upside of the root, here we have a root of vn, here we have vn. So one root vn, this vn will be cancelled, remaining on the left hand side will be root vn. On the right hand side we will be having 1 by 4 pi epsilon 0 e square by nh by 2 pi. All good, fine. So in order to get the absolute equation for velocity of electron in the nth orbit, Vn is equal to, removing the root from all the sides, Vn is equal to 1 by 4 pi epsilon 0 e square, okay, by h by 2 pi into 1 by n. Matlab, you can see that velocity of electron in the nth orbit is equal to 1 by 4 pi epsilon 0 e square h by 2 pi, which is a constant, into 1 by n. So I'm going to write velocity of electron in the nth orbit is equal to some constant v0 divided by n. This is the important part. Matlab, the velocity is inversely proportional to the orbital number. ये बहुत ओके, ये तो बहुत 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 इम्पोर्टेंट है ब्रो. चलो, बहुत इम्पोर्टेंट है. Okay, so this is actually the equation to find out the speed on the nth orbit for hydrogen atom. For hydrogen atom, ठीक है. For hydrogen like atom, we are not knowing the derivation formula. I'm going to write it for, because it is not there for your CBSE syllabus, it will be there for your NEET or JEE exam. For hydrogen like atoms, right, speed on the nth orbit will be equal to z divided by n into v0. Z मतलब atomic number. Z तो पता है सबको, है ना? पर चलो, पता है क्या नहीं? Z तो पता है सबको, पता होना ही चाहिए. Atomic number, right? So for hydrogen like atom, velocity or speed of electron in the nth orbit is z by n into v0. V0 is a constant. Clear? Everyone? Jack Matthew, sir, in the timetable schedule, what? Okay, done. So we got a formula to find out the speed of nth orbit for hydrogen and hydrogen like atom. It is very important. ठीक है. ठीक है भैया, आप अपनी स्पेशल क्लास को रीशेड्यूल कर देते, बट नॉट दिस क्लास भैया, व्हाई यू हैव डन दिस. अरे अभी तो ओके, व्हाई एट दिस पॉइंट ऑफ टाइम क्लासेस आर हैपनिंग. अरे बहुत सारे क्लासेस आर हैपनिंग, सो मेनी थिंग्स आर हैपनिंग. मतलब आई टोल्ड यू आई बी लीविंग दिस प्लेटफॉर्म ऑफ Unacademy विद इन दिस मंथ. सो मेनी अरेंजमेंट्स, रीअरेंजमेंट्स तो हो रहा है. Right, for this month classes won't be so regular and proper, let me tell you beforehand. Okay, so इसीलिए we are having the classes at some random times like this. ठीक है, I'm just adjusting myself and taking the classes. I know that you all are going through this, exams are coming, I'm really sorry for that. I'm trying my best, लेकिन this is what is happening. ठीक है? Fine. Okay, ठीक है. Okay, fine. So we'll be proceeding further. So we got the speed का formula मिल गया, हम radius of each orbit का formula मिलना ही चाहिए. Let's find out. Okay, let's see how this can be done. Very simple. We know MVR, which is angular momentum, is equal to NH divided by 2 pi. है ना? Now we are going for an equation for radius. R is equal to NH divided by 2 pi. Right? Okay, we want R. This will be equal to mass into speed. M into V. Alright? NH divided by 2 pi. Not a big deal. Into mass into. अरे V का formula we already know. What is V का formula? We have to write the actual formula, which is 1 by 4 pi epsilon 0, right? E square by h by 2 pi. I'll write it. V is equal to 1 by 4 pi epsilon 0. ठीक है, 1 by 4 pi epsilon 0 फिर क्या है? E square by h by 2 pi. E square by h by 2 pi. और क्या है? Right, then 1 by n into 1 by n. Would this be the formula for radius here? Yes, of course. So just start rearranging. This n will go up and join with this n, that will be n square. ठीक है, ये h by 2 pi है. This h by 2 pi will also go up. So what we have is h by 2 pi the whole square. Fine. What else we have? मेरा बच्चा लोग बोल दो ना जरा. E square we have here, right? देख ले, E square तो मिल गया. So I hope everything is done. What is remaining is 1 by 4 pi epsilon 0 into m. Okay, that will be going up, है ना? 4 pi epsilon 0. It is 1 by 4 pi epsilon 0. It will go up. So 4 pi epsilon 0. This mass will be remaining. राइट देख ले, h by 2 pi ऊपर हो जाएगा. ये तो ये ओके. E square will be on the numerator. अरे वाह, कर क्या रहा है सर आप, है ना? कर क्या रहा है सर? ओके, so E square will be on the denominator itself here. देख ले, I forgot about this line here, right? And remaining things are same. हाँ, this is what we get, isn't it? Yes sir. Now we know h by 2 pi का value. H is Planck's constant, 6.6 into 10 power minus 34. 2 pi E is electronic charge, which is 1.6 into 10 power minus 90. 4 pi epsilon 0 का value 8.85 into 10 power minus 12. If you apply all these values, what you're gonna get is 0.529 Armstrong. मतलब the radius of the nth orbit का formula ये है कि that is equal to n square into 0.529 Armstrong. How I got 0.529? By supplying the value of h, 2 pi e square 4 pi epsilon 0 mass of electron. After substituting that, where we know the value of all these things, हमको मिल जाएगा 0.529. Very simple, right? Not a big deal. So radius of the nth orbit is equal to n square into 0.529 Armstrong. So tell me, okay, if this is the equation, what will be the radius of first orbit of hydrogen? Putting n equal to 1, that is equal to 0.529 Armstrong. So the radius of first orbit of hydrogen atom is 0.529 Armstrong. How I got it? Put n equal to 1 there. मिल जाएगा, खुश हो जाएगा आप लोग. ठीक है, fine. For hydrogen हैप्पी चॉकलेट डे. ऐसे भी कुछ दिन है क्या? पता नहीं था. आई डिडंट नो दैट. हाय सरजी, हाय अहमद. ओके, सो हैव यू ऑल कॉपीड दिस टिल नाउ? इधर तक कॉपी हो गया? R1 is equal to 0.529 Armstrong. This is the equation for hydrogen atom. So I am just giving you directly, right, for hydrogen like atom, just like a helium plus, lithium 2 plus, where only one single electron is revolving around the nucleus. Both are hydrogen like atoms. Okay. In that case, radius of the nth is formula as n square by z is the atomic number of hydrogen like atoms into 0.529 in Armstrong. Clear? Okay, this is very important. So we got the formula for radius of nth orbit. Okay, the speed of electrons revolving on the nth orbit, that is also done. Now एक तो बाकी है. ओके, एक तो बाकी है. दयवाയി ഞങ്ങളെ अरे I'll be here somewhere here, obviously I'll be there, right? You all can join my classes, I'll be telling you. ठीक है, don't worry, don't worry, don't worry. मैं तो इधर ही हो जाएगा. I'll be here somewhere, I'll be telling you. ठीक है, fine. इधर तक हो गया ना? चलो. Okay, so speed का formula मिल गया, radius का formula मिल गया. Now left, what is left? We have to find out the formula for energy. We know that each and every stationary orbit is allocated with a specific amount of energy, right? And we have learned that in the first postulate, right? Those orbits with a specific steady amount of energy will only be existing. So it is very much necessary to find out the energy of each and every orbit. Kaise? Now, in yesterday's class, those who do remember, who came to my classes, who's taking the classes regularly, energy of nth orbit का formula ये था minus 1 by 8 pi epsilon 0 e square by r. Okay, energy of the nth orbit का formula था minus 1 by 8 pi epsilon 0 e square divided by r. ठीक है. Now here r is an unknown, but we already have the formula for r here, 1 by 8 pi epsilon 0 e square by r का value कितना? What is the formula for r? n square by m. I'll write it. N square by m. Then what do we have? H by 2 pi the whole square into h by 2 pi the whole square into what else we have? What else we have? 4 pi epsilon 0 by e square. 4 pi epsilon 0 divided by e square. Okay, देख ले, other than 1 by n square, देख ले, other than 1 by n square, don't we know the value of all these things? E square, 8 pi epsilon 0, h pi 2 pi, 4 pi epsilon 0, e square, mass of electrons का सबका value हमको पता है, right? है या नहीं? Don't we know? Yes. So just substituting all those values and getting the numerical value, we'll get it as 2.18 into 10 power minus 18 joule. By substituting all the values here in that equation, okay, we don't have to check it, bada calculation hai, right? So during the time of derivation, you can simply say by substituting the value of n, m, e square, h, 2 pi's, 4 pi epsilon zeros, what you will get? You will be getting a value of 2.18 into 10 power minus 18 by n square. So देख ले, आसानी से हमको मिल गया energy of the nth orbit. If you want to find out energy of the first orbit, 1 by n, put it as 1 square. If you want energy of the second orbit, put n equal to 2 here. Very simple. Clear? बहुत सही है ना? बहुत सही है, ठीक है. देख ले, when the unit is expressed in joules, it is coming as 10 power minus 18. बहुत छोटू value, isn't it? Right? So it is better to express the energy in chotu unit, which is a chotu unit, electron volt unit. ठीक है. Now tell me, electron unit, electron volt and joule का conversion क्या है? 1 electron volt is equal to 1.6 into 10 power minus 19 joule. ठीक है. So 1 joule is equal to 1 divided by 1.6 into 10 power minus 19 electron volt. तो इतना जूल is equal to इतना into 1 by 1.6 into 10 power minus 19. मतलब we're converting this joule into electron volt divided by 1.6 into 10 power minus 9, 2.18. कितना मिल जाएगा? We'll get that 13.4 by n square with a negative sign in electron. ओके 13.4 नहीं 13.6 है. अरे वो चेंज कर ले, ठीक है, चेंज कर ले, 4 नहीं, once we get it 13.6. So energy of nth orbit is equal to minus 13.6 by n square. आ गया समझ? Which means देख ले, everybody listen here. If the energy of nth orbit is minus 13.6 by n square electron volt, इसका मतलब ये कि if you take hydrogen atom, if you take the first orbit, energy of the first orbit होता है minus 13.6 by 1 square, which is minus 13.6. Energy of the second orbit E2 होता है minus 13.6, putting n equal to 4, minus 13.6 by 4, that is equal to 3.4 minus. Yes or no? है या नहीं? हाँ हाँ बिल्कुल बिल्कुल बिल्कुल. साक्षी पाहुजा, yes, I obviously know her. She takes classes in the same platform, है ना? तो I know that in that way. I don't know her personally though. Fine. Is it clear? So similarly, putting n equal to 3, we'll get the energy of the third orbit. Put n equal to 4, we'll get the energy of the fourth orbit. By putting n equal to n itself, we'll get the energy of the nth orbit. Simple as that, right? Not a big task. मिल गया समझ? Is the concept clear to every one of you? Very important it is, बहुत important है. Everyone, आ गया समझ? Clear है ना अच्छे से? Without having trouble with any of the concept, I hope it is wonderfully clear. Okay, ठीक है. We'll start doing the problems. I know that we were continuously doing lot many concepts till now. I know that you all will be like, sir, give us some questions. We want to practice doing some questions on the theory, right? So let's start doing the problems here. ठीक है, श्वेता क्लियर? ठीक है, तो कर ले ये क्वेश्चन. Jack Matthew, अरे thank you so much for all the love and care you're giving me. Thank you so much, means a lot. Shama Khadija gives the answer as option B, which is plus 13.6 by 9 electron volt. सही है. ठीक है, I'll just tell you. Everybody, listen to me. Question is, how much energy is required to knock out an electron from the third orbit of a hydrogen atom? ठीक है, how much energy we have to give? That's a question, है ना? देख ले. First, let us find out the energy possessed by an electron in the third orbit. ये तो nucleus है. First orbit, second orbit, third orbit. Tell me, what is the general formula for the nth orbit electron in an nth orbit? Minus 13.6 divided by n square. है ना? ठीक है. Now, as we are talking about the third orbit, the energy possessed by electron in the third orbit is equal to minus 13.6 by n takes 3, because we are talking about third orbit, so 3 square is 9. मतलब the energy of an electron in the third orbit is minus 13.6 divided by 9. Okay, इसका मतलब क्या है? मतलब what does that negative sign corresponds to? Very simple. We know that from 0, if we giving energy to a body, Okay, we keep on giving energy to a body. Tell me what happens. Energy increases. Energy तो बढ़ जाएगा, है ना? Energy तो बढ़ जाएगा. Energy increases from 0, 1, 2, 3, 4. Now let's say from a body of zero energy, if we are taking energy from it, okay, what will happen? From zero, if we take some value, right, the energy go to the negative. समझ में आ गया? Let's say from a body which is already having a 0 joule of energy, I'm taking 2 joules. Tell me what will be the current energy of the body? -2 हो जाएगा. ठीक है? ठीक है? Awesome. Very good. Now देख ले. Listen to me very carefully. Everybody listen here. Okay? देख ले. Now here the electron in third orbit is -13.6 divided by 9. मतलब, right, the electron which is existing in the third orbit is losing -13.6 divided by 9 इतना energy from it, so that it can be more stable. मतलब a body with lesser energy will be more stable. So it has lost this much of energy to attain stability and to be in this third orbit. Now tell me, if you want to take out this particular electron from the third orbit to the infinity position or away from the nucleus, कितना energy देना पड़ेगा? It has lost this much to come to the third orbit. So if you want to leave, how much energy देना पड़ेगा? अरे इतना energy देना पड़ेगा, 13.6 divided by 9. This much of energy has to be given to the electron for taking that electron from the third orbit to an infinity position or away from the nucleus. Okay. Bye, Miara. Okay. See you in the next class. Means a lot, Jack. Deepak, hi. समझ में आ गया? How the answer is coming as option B. अच्छे से. Chocolate. Tell me what is the speciality of this chocolate day, or why we are having this particular day as chocolate day? I have no idea. Any reason for celebrating this particular day as chocolate day? कुछ है क्या? Okay, ये तो atoms. Anyone? Question is right in front of you. If anybody knows the answer for this, you all can post it here and let me know. जल्दी फटाफट. Anyone? Very good, it's option C. Very good. Who said Roman? Very good, awesome. देख ले. Using the known values for hydrogen atom, calculate the radius of third orbit of Li2+. Tell me, what is the formula to find out the radius of nth orbit for hydrogen like lithium 2+ is hydrogen like atom, not hydrogen, right? Formula क्या है? n square by z into 0.529 Armstrong. है ना? Yes. Tell me, for which orbit of lithium atom the question is asked to find radius? Third. So n will take 3 square by z, atomic number of lithium, it's 3 into 0.529. 3 square by 3 is 3 into 0.529 is 1.587 unit Armstrong. देख ले कितना सही है, ऑप्शन सी मिल गया. Isn't it? We simply have to use our direct formula to find out radius. Substitute the values, get the answer. Wow, happy. That's it. Yes or no? है ना? जी हाँ. मैं तू खलनायक. Next one. Okay. Using the known values for hydrogen atom, calculate the angular momentum of electron in the third orbit of helium plus. Angular momentum is asked. It's one of the simplest question. इतना सिंपल कभी नहीं मिलेगा जिंदगी पे ऐसा वाला सवाल. Answer. Array answer is option C. Array for any atom let it be, right? For any atom, the angular momentum का formula is NH divided by 2 pi. Okay, so here we are talking about whether it is a hydrogen, helium, lithium 2 plus, whichever it is, right? The angular momentum का value is NH by 2 pi. Here we are talking about third orbit. So n will take 3. So 3h by 2 pi will be the answer, which is option C. सही है, right? Aman, Adil, Deepak, Shweta, Sharwari, yes, yes, बिल्कुल, awesome. ठीक है, related to energy levels, line spectra, okay. So ये सब clear है? Now it's time to learn about a new concept, which is very important concept, and I want the attention from every one of you. ठीक है? If you all are ready, we can start with it. Those who are ready, just raise your hands in the chat box and tell me. Yes, sir, we are super duper ready here. Good evening, Angel. Deepak, see here, sir. Hello, Lakshita. Shall we discuss the concept of atomic spectra? Right. Before starting with atomic spectra, first we will see what is a spectrum, right? Okay, for that, I just need to tell you this simple word, everything will be coming into your mind. Electromagnetic spectrum. याद है? What is electromagnetic spectrum? The continuous arrangement of all the electromagnetic waves on the increasing or decreasing order of frequency or wavelength, right? I hope you do remember. Here we have gamma rays, here we have X-rays, UV hai, visible light hai, then infrared hai, radio waves hai. Now all these waves are arranged to the right in the increasing order of wavelength and to the left in the increasing order of frequency. Isn't this right? So this arrangement of all the frequency or wavelength in the increasing or decreasing order, we call it as a spectrum. Okay, this we call it as a spectrum. समझ में आ गया? ठीक है. From the spectrum, ठीक है, take a small range of the spectrum, मतलब take only the visible light का spectrum. Visible light, which means the violet, indigo, blue, green, yellow, orange, red. We all know that, right? The visible spectrum has a minimum wavelength of 400 nanometers and a larger wavelength of 700 nanometer, where 400 corresponds to violet and the largest wavelength of 700 corresponds to red. Among these two colors, we have the 5 remaining colors: violet, indigo, blue, green, yellow, orange, red. This 7 different colors. Do you think that only these 7 different colors are only there in the visible light? Matlab, after 400, let's say this indigo color is having a wavelength of 450 nanometer. This is not the actual value. May approximate karke. I just told you a value. Indigo is having a wavelength of 450 nanometer. Blue will be, let's say it is having a 500 nanometer. My question is, right, after a wavelength of 400 nanometer, which is for violet, is it the next wavelength in the spectrum? Is it going to be 450 nanometer? Bilkul nahi. Though we are mentioning only 7 different colors, right, from violet with 400 nanometer wavelength, there will be very next wavelength very close to it, let's say 401 nanometer. Then there will be a wavelength of 401.11 nanometer, 401.12 nanometer. All these wavelengths will be present. Matlab, starting from 400 to 700, infinite number of such wavelengths will be present. Not a single wavelength will be missing. Pura ka pura infinite number of such wavelengths will be there. So such kind of spectrum without missing a single wavelength, we call it as continuous spectrum. Okay, what do we call it? Continuous spectrum. How can we define? कैसे define कर सकता है? अरे very simple, right? Spectrum, which is the arrangement of all the radiation in its increasing or decreasing order of frequency or wavelength. That is spectrum, right? Spectrum without missing any wavelength or frequency from it, lambda wavelength frequency है, right? That kind of spectrum we call it as continuous spectrum. मतलब हमारा electromagnetic spectrum होता है continuous spectrum. ठीक है? ठीक है ना? This will be continuous spectrum. ठीक है? तो understood what is spectrum, what is continuous spectrum, and now you need to know atomic spectrum क्या आता है. Very very simple, right? The spectrum obtained from atoms. You know what is spectrum, right? This arrangement of radiation, right? This radiations obtained from the atom, we call it as atomic spectrum. Very simple. Spectrum obtained from atoms, we call it as atomic spectra, and we have two different kinds of atomic spectra. Shall we go in detail with that? Which are the two different kinds of atomic spectra, everyone? Everyone listen to me here on the concept of this atomic spectra. Very important. Very important मतलब super duper duper का भी ऊपर वाला important. Fine, देख ले. First kind of spectrum is called as absorption spectrum. For absorption spectrum, as we already know the Bose model, it will be easy for us to understand. Fine, now let's say this is the hydrogen atom. ये हमारा nucleus है, and there is one single electron in the first orbit. ठीक है? Now to this particular hydrogen atom, I am giving a continuous spectrum, okay, with a minimum value of lambda 1 and a maximum value of lambda 2. मतलब there is a wavelength between the entire innumerous number of wavelengths ranging from lambda 1 to lambda 2 is there. ठीक है? So continuous spectrum is given. Spectrum का मतलब क्या है? अरे different wavelengths or different radiations or different energy, let's say. Okay, so when I say a spectrum is given, it means that energy is being given. Spectrum का मतलब क्या है? Spectrum has so many radiations, right? Light is also a radiation, light is also an energy, light energy. So similarly, we are giving a continuous spectrum or continuous energy is being given to the atom. Tell me what happens, right? From this entire spectrum, if there is an radiation corresponding to the energy equivalent to the difference of energy between these two orbits. Let's say this is having an energy of 1 joule, second is having an energy of 2 joule, right? Now, if the incoming radiation has an energy equivalent to 1 joule, क्या हो जाएगा? That 1 joule will be accepted by this particular electron and will be moving to the second orbit. Yes or no? Yes or no? Yes. So what happened in our spectrum? From the spectrum, energy corresponding to or radiation corresponding to 1 joule is being taken. So what happened? When this radiation after passing through comes out, that particular radiation will be absent. है या नहीं? है या नहीं? That particular radiation will be absent. मतलब this region will be acting like a dark region there, right? Now now the electron is in the second orbit after absorbing some energy. Now in the incoming radiation that is coming, if there is a radiation which has an energy equivalent to the difference in energy between the second and third, what will happen? Electron will absorb that energy. It will move from the second orbit to third orbit, right? So if an electron moves from second to third orbit by absorbing some radiation of a specific wavelength, what happens? Yes, from the spectrum, that particular energy will also be gone. Okay, so in the absorption spectrum, whenever a group of radiation is passed through the spectrum, or when it is passed through the atom will be absorbing some of its energy or some of the radiation, where, right, that radiation will be missing from the spectrum. As that kind of spectrum we call it as absorption spectrum. समझ में आ गया? Is it clear? Whichever radiations are being absorbed, that will not be coming out after it passes through the atom, as it won't be there. If we draw the spectrum, matlab that arrangement of all the radiation, some radiations will be missing. Okay, so those radiations will be showing a dark region, whereas in the remaining regions, where in these regions colors will be obtained. देख ले, ये सब colors होता है. This will be colored region. These two lines will be having corresponding to dark region, and that corresponds to those radiation which are being absorbed by the atom. सही है? सही है? And this lines which corresponds to the radiation absorbed, we call it as spectral lines. This lines we call it as spectral lines. Is the concept clear? Clear, clear, clear. Simple, simple, clear. This is called as the concept of absorption spectrum. Okay, very good. Now do you want to know what is emission spectrum? Emission spectrum क्या होता है? देख ले, वो भी बहुत सिंपल है. ये हमारा न्यूक्लियस है. Okay, after it goes through this absorption spectrum process, right, the electron is in the third orbit. इधर ही है electron of the hydrogen atom. Okay, so whenever it is in the higher orbit, right, electrons will be having higher energy and less stability. Tell me what will these electrons will do? Very simple. These electrons, in order to attain stability, it will be moving from the third orbit to the second orbit. Right? When it moves from the third orbit to the second orbit, what will be happening? Right? The energy or the radiation corresponding to this energy difference will be released. Okay, so if we mark it right here in the increasing order of frequency or wavelength, I can mark a single line which corresponds to the radiation that is being emitted during the transition from the third to second. Similarly, this electron will again be unstable in the second orbit, so it will be moving from second orbit to the first orbit by again releasing a radiation corresponding to the energy difference between the second and the first orbit. समझ में आ गया? मतलब during the transition in this particular case we will be obtaining two spectral lines corresponding to radiation that is being emitted during electron transition. Clear? मतलब these two lines will only be colored and the remaining regions will be so dark. So this will be dark regions. Look into the absorption spectrum and the emission spectrum. Do you find any relation between that? Do you find any relation between these two? What is absorption spectrum and emission spectrum? Have a look at it. देख ले, during the time of absorption spectrum, whichever radiations are being absorbed or whichever is appearing as dark lines there in the absorption spectrum, right, during the emission spectrum, right, the same amount of energy is being released Do you agree with me on that? आप सब लोग agree करते हैं इस पे? Isn't it? Yes. So when a third electron, when electron in the second orbit move from the third orbit, it absorbs some energy, right? Same energy will be released when it moves from third orbit to second orbit. Matlab, in the absorption spectra, that will be a dark region because the radiation is being absorbed. But in the case of emission spectra, that spectral lines will be a bright region, Q. Because during emission spectra, right, the same amount of energy is being released when it moves from third to second. Clear हो गया? मतलब that absorption spectrum and emission spectrum, if you keep one over the other, it will be perfectly matching. That's what I want to say. अब मिल गया कॉन्सेप्ट? और बता दें, हाँ सर थोड़ा थोड़ा मिल रहा है कॉन्सेप्ट, आ रहा है दिमाग पे. Any doubts you have, you can tell me, express here. कोई भी डाउट्स है तो बता दें. क्लियर है ना अच्छे से? कोई भी डाउट्स नहीं, राइट? Okay, so have a look at it. I'll be coming back within 2-3 seconds. ठीक है, अभी आएगा. तो सही है, मिल गया ना कॉन्सेप्ट पूरा का पूरा. Okay, so absorption spectrum, emission spectrum, got the entire concept. Let's see what is called as spectral series. Red तो अच्छा नहीं है, over black, right? I think white will be better. Spectral series क्या होता है? देख ले, we already have seen here, right, some lines in the atomic spectrum, or let's say absorption or emission spectrum. We have seen lines here that are called as spectral lines. So ठीक है, so spectral series is that, okay, those spectral lines which follow common features, okay, we call that spectral lines. Okay, so or spectral series. There are so many spectral lines we already know, right? So in those spectral lines, if they are sharing, okay, or if they have some common features, then we call those combined or this entire group of spectral lines as spectral series. ठीक है, समझ में आ गया? Okay, so let's see what are those common features the spectral lines will be sharing and what all different spectral series we can obtain. Okay, fine, देख लें. The first spectral series was being found out by the scientist Balmer, and those series was given the name of Balmer series. Okay, Okay, that is being called as Balmer series. Let's see है ना ये Balmer series क्या होता है. अरे very simple है. Okay, बहुत simple है. Now we already know if we have a nucleus and if there are orbits and if there are electrons on one of the orbits, higher orbits, है ना, this electron will be having a tendency to move from higher orbit to lower orbit Q so that it can attain more stability. So during its transition, as we already have discussed, what will be emitted, right? Photons will be emitted. Matlab light energy or electromagnetic radiations will be emitted, right? So Balmer found out that Balmer found out a specific spectral series where the wavelength of all the photons emitted, lambda, is within visible light. So we know that during the transition of electrons, right, photons or light energy is being emitted, right. The scientist Balmer found out a group of spectral lines which comes under the wavelength of visible light. And those spectral lines, or that combination of spectral lines, we call it as Balmer's spectral series, or in simple, Balmer series. Okay, so Balmer series corresponds to all those spectral lines within visible light. Fine. Okay, this was the first found out spectral series, and there is a reason for this series to be the first. Why? This series corresponds to the visible light. So obviously, if a photon corresponding visible light is being emitted during electron transition, it is visible with our eyes. Okay. Now he found out that this Balmer series or visible light is being emitted whenever an electron makes a transition from any higher orbit to second orbit. Any higher orbit, let's say, matlab if it is moving from 3 to 2, if it is moving from 5 to 2, if it is moving from 7 to 2, from any higher orbit, if the electron is jumping to the second orbit, right, photons or radiation corresponding to visible light is being emitted, right, and this spectral lines we call it as Balmer spectral series or Balmer series in simple. Fine, sahi hai. Now what we need is, we should be having a formula for this emitted wavelength when electron makes a transition from third to second, fifth to second, seventh to second. We need a formula, right? Okay, it's very simple. We'll derive in the next page. Dekh. In general, Balmer series is obtained when electron jumps from any nth orbit to the second orbit. So n initial is Ni and n final is equal to 2. It is in that case, right, we will be obtaining a photon or a radiation in this visible light series. So tell me, if an electron moves from a higher orbit to a lower orbit, isn't an energy being released? Yes, just now we have discussed. Uska energy ka value kitna hai? The energy of the photon release is equal to the difference in energy of the orbits. Matlab energy initial minus energy final. Got it? So tell me, what is the formula for energy of nth orbit of hydrogen? Minus 13.6 divided by n square. Minus, what is the energy of the final? Final is equal to the second orbit, so that is minus 13.6 divided by 2 square. Arey, this energy is in which unit? मेरे बच्चे लोग बता दे. This is in electron volt, but the formulas, all the calculation has to be done in joule. So how can we do that? By multiplying it with 1.6 into 10 power minus 90. Fine. Okay. Now, as we all know, we started this calculation for finding out a value for wavelength during its transition, right? कैसे करेगा? अरे E का value h nu है. E is equal to h into frequency, and frequency is equal to c by lambda, velocity of radiation divided by its wavelength. So we substitute कर सकता है. E is equal to h c divided by lambda is equal to this. ठीक है. keeping 1 by lambda here and taking this 13.6 outside, 13.6 into 1.6 into 10 power minus 19 divided by this h and c go as the denominator to the right hand side, value is 6.6 into 10 power minus 34, h Planck's constant, and 3 into 10 power 8 the value of radiation, that is equal to 1 by minus of minus will become plus, है ना? Okay. Here up करेगा and we'll add this, minus of minus will become plus, and this will be 1 by 2 square minus 1 by n square. ठीक है, clear? Okay, so after substituting all these values, we'll be getting a constant value which is Rydberg constant into 1 by 2 square minus 1 by n square. So this will be the formula for wavelength emitted when electron moves from any higher orbit of n to the second orbit. ठीक है, formula मिल गया. So this will be the entire set of wavelengths that we emitted within what? Within the Balmer series. ठीक है, ये तो very important है, बहुत important है, don't miss it. सही है. Okay. Yes. Now I'll give you some extra information also. Now the final has to be to the 2. Now if the electron is jumping from third to 2, we call it as alpha Balmer series, alpha spectral lines. If it is moving from 4 to 2, we call it as beta 1. ठीक है, and as it is. If it is closest, that will be alpha, and if it is the next one away, that is beta, then comes gamma, and I say it keeps on going. And one more thing, we'll take the next page. Nucleus, first orbit, second orbit, third, fourth, fifth. Now देख ले, second है, दे तो third है. Now if it is moving from third to second, we know that the difference in energy between them is the least, है ना, compared to other electronic transition. Now if it moves from 3 to 2, energy will be lesser. Energy is equal to h nu. So if energy is less, the frequency of the emitted photon will also be less, and you know that frequency is equal to c by lambda, inversely proportional. So when frequency is lesser, wavelength will be maximum. मतलब whenever electron is making the transition between two close orbits, right, the energy of the photon emitted will be lesser and the wavelength will be maximum, right? So how I understood that this energy is lesser? We already know the energy of the emitted photon is equal to difference in energy of the orbits. Difference in energy of the orbits, right? So we already know that the difference in energy of the orbits will be minimum between the orbits that are very close. So here in this case of Balmer, it will be between 2 and 3, which is the closest. So there we can have the minimum energy release and maximum wavelength possible. Clear? So as we move away, let's say if it is moving from 3 to 2, energy will be increasing, 4 to 2 increasing, 5 to 2 energy increasing. Okay, if it keeps on moving away from the nucleus, and if it is finally jumping to the second orbit, energy तो बढ़ जाएगा, right? So tell me, when can we have the maximum energy in the Balmer series? When an electron jumps from the infinity to the second orbit. because there the difference in energy will be very higher. So this can help for the emitted photon to have very large energy. ठीक है? Okay, energy will be max in this case and wavelength will be minimum in this case. ठीक है? वीडियो प्रॉब्लम, वीडियो पे क्या प्रॉब्लम है सौरभ, बता दे। वीडियो पे प्रॉब्लम क्या है मेरा बच्चा लोग? सब सही है ना? Everything is good I suppose, no problems I suppose, सब सही है, isn't it? और क्या? Okay, now we have learned about Balmer series. Fine. Now we'll learn about all the other spectral series that is existing. Okay, before going with that, thoda और concept है, then we'll start doing the problems from here. देख ले. Everybody listen here. When the electron is jumping from the nth orbit to the second orbit, the wavelength of the emitted photon is given by the formula of a Rydberg constant into 1 by 2 square minus 1 by n square. So can't we make a general formula here? Yes, we can. देख ले, if the electron is moving from n initial to some n final, the wavelength of the emitted photon is r into 1 by n f square minus 1 by ni square. Okay. New concept. Okay, so ठीक है, you all can note this down also. तो हम तो जा रहा है. Now Balmer series तो हो गया. It is the series of spectral lines which is existing in the visible region. ठीक है. Now we have Lyman series. Okay, these are the spectral lines existing within the UV region. Now the scientists found out that the spectral lines or the emitted radiation will be having a frequency or wavelength within the UV region when electron jumps from any higher orbit to the first orbit. Okay, from any higher orbit to the first orbit, if an electron is jumping, we can have Lyman spectral series. Matlab this corresponds to a group of spectral lines which is lying in the UV region. ठीक है? ठीक है? This is Lyman series. Now similarly we have Paschen series, Brackett series and Fund series. The speciality of all these series is that this will be coming within infrared region. And Paschen series is obtained, right, a spectral line within the UV radiation is obtained when electron jumps from any nth orbit to the third orbit. Bracket from nth orbit to the fourth orbit. Fund from nth orbit to the fifth orbit. Okay, yes, I lost him. हाँ, फन सीरीज बिल्कुल सही है. ठीक है, समझ में आ गया? We have Paschen series, Brackett series, Fun series, and in which cases it happens and in which electromagnetic region it is falling into. All the concepts clear है ना सबको? अच्छे से, without having any doubts. Clear? So if all the concepts are clear, we'll start doing the problems, है ना? कर ले, start doing the problems, everyone. Very good. A and K. Do this problem. Ratio of wavelength of the last line. Last line matlab jumping from the infinity to the corresponding orbit. In the case of Balmer, it is to the second, and in the case of Lyman, it will be jumping to the first. हो गया? Anyone? Answers? See, 0.5. Okay, I'll explain. देख everyone. Question is related to the wavelength. So first let us write down the formula. Rydberg constant R into 1 by n final square minus 1 by n initial square. This is a formula. Now, question is to find out the wavelength of last line of Balmer series. Last line का मतलब ये कि it is jumping. Initially it is at infinity, and in the case of Balmer series it will be jumping from infinity to 2 for Balmer. Okay. So similarly for Lyman, okay, for the Lyman series, the last line will be from, and initial will be from infinity itself, and it will be jumping to a final of first orbit. ठीक है? Fine, सही है ना? Now we can substitute these values for finding out the ratio of wavelength and get it done. Now we know that the wavelength of Lyman series 1 by lambda of L, Lyman series is equal to R into 1 by n final square, that is 1 by 1 square minus 1 by n initial square, okay, 1 by infinity square. Similarly, 1 by wavelength of Balmer is equal to R into 1 by n final square. In case of Balmer, it comes to finally 2 minus 1 by initial square. Initially, it is at infinity square. 1 by infinity, दोनों 0 है. So, first equation, second equation. So, what we can do is first equation by second equation. Okay. So 1 by lambda L divided by 1 by lambda of Balmer. So lambda Balmer goes up, divided by lambda of Lyman. Okay. So R by 1 square हो जाएगा because 1 by infinity 0 है. So R by 1 square is R. Here to R into 1 by 2 square minus 1 by infinity square. 1 by 2 square is 1 by 4. So R cancel हो जाएगा. 1 by 1 by 1 by 4. 4 तो ऊपर आ जाएगा. सही है? बोल दे हाँ सर बिल्कुल सही है. वेरी गुड शर्वानी. ऑप्शन इज नॉट सी, ऑप्शन बी है हमारा. ओके. Let's do this. The diagram shows the energy level for an electron in a certain atom. Which transition represents the emission of a photon with most energy? हो गया? Anyone? बता दे. Okay, I'll tell you. This one is correct. Okay, देख ले. From the diagram given, you are asked to find out that transition which emits photon of most energy. देख ले. For emission of a photon, the transition has to be from higher energy to lower energy. देख ले. In this case, and in this case, right? Electron is moving from higher energy to lower energy so that it emits photon. But in the first case, it is moving from lower energy to higher energy, so it will not emit photons. So first one is not our answer. It will not emit. So among these three, you have to find out which emits more amount of energy. How can we find that out? Very simple. The energy of the photon emitted is equivalent to difference in energy of the orbit. Okay. So during whichever transition there is a large difference in energy of orbit, that will be emitting out most energy. So for that, let us find out the energy of each and every orbit. What's the formula? Energy of the nth orbit is minus 13.6 divided by n square. So finding out the energy of the first orbit, put n equal to 1, that is minus 13.6. Okay. Right? Now for finding out the energy of the second orbit, putting n equal to 2, so 2 square is 4, minus 13.6 divided by 4 is minus 3.4. Then for finding out the energy of third orbit, minus 13.6 by 3 square, 9 goes almost I am writing 1.5. Okay, so this will be very chotu value, minus 13.6 divided by fourth orbit by 16. Nannu munnu. देख ले, in the second case, the difference in energy is nannu munnu value and 1.5. So it will be somewhere around 1.5 itself, right? Okay. In the third case, it is moving from 3.4 minus 3.4 to 13.6. So difference in energy is minus 13.6 minus 3.4, almost 10.2. Here difference in energy, which is equivalent to the energy of the photon emitted. देख ले, in the last case, it is moving from nannu munnu value to minus 3.4. So difference in energy is almost around 3.4. So tell me, which has a larger difference in energy in this case? Yes or no? Yes. So wherever we have a larger difference of energy, there the emitted photon will be having a larger value. So it corresponds to option 3, and here we are. Right? Got it? Okay. We have one more question here. Everyone अच्छे से कर ले. जल्दी जल्दी जल्दी, फटाफट जल्दी. Samajwadi, okay, says the option B it is. Okay, so the correct answer is option C मेरे बच्चा लोग. ठीक है, देख ले, I'll explain. If the wavelength of the first line of the Balmer series is 6561, tell me what do you mean by the first line of Balmer series when it moves from third orbit to second orbit? The wavelength is 6561. We can write the formula also. We know the general formula is 1 by lambda is equal to R into 1 by n final square minus 1 by n initial square. Substituting the values for the same. 1 by lambda is 6561 is equal to R into 1 by what is the final second, 2 square minus initial is 3 square. Now question is to find the wavelength during the second line of the Balmer series. Second line matlab it moves from fourth to second. So formula will be 1 by lambda is equal to R into 1 by 2 square minus 1 by 4 square. Let's say this is first equation, this is second equation. We can do first by second. R will be cancelled, the only unknown will be lambda. By solving we will get it as 4860 Armstrong. ओके आसानी से मिल जाएगा. हैप्पीली मिल जाएगा विदाउट एनी फर्दर इश्यूज. ऐसे एनी डाउट्स एनीवन? कोई भी नन्नू मुन्नू डाउट्स है? क्लियर सब? Okay, so that is also over. One last concept is just waiting for us. De Broglie's explanation of Bohr's second postulate. Okay, Bohr का second postulate क्या था मेरे बच्चा लोग? The angular momentum L is equal to NH divided by 2 pi. He said that only those orbits exist, or electrons will be revolving in only those orbits where the angular momentum L is an integral multiple of h by 2 pi. Isn't this what he told? Yes, this is what he told. Right. So current explanation for the second postulate of Bohr was given by the scientist de Broglie. And we all have learned about de Broglie, na, from the dual nature chapter. What he told? De Broglie told that any particle will be associated with a wavelength, and the wavelength associated is given by the value of h by p. Okay, so he used the same concept of dual nature of particle and he explained the same. Do you know how? देख ले, nucleus है, ये हमारा orbit है, let's say one of the orbit with some radius Rn, and the electron is revolving in this particular orbit. Electron तो ऐसे revolve कर रहा है. Electron is moving. When a charged particle move, it will be associated with a wave. Right? Okay. Now he told that the wave that is being produced by this electron, okay, the waves produced by those electrons revolving in a particular orbit, right, should be equal to, okay, should be equal to the circumference of the orbit through which it rotates. What did he say? He said that if an electron is revolving in a circular orbit, right, and if it wants the electron to be stable in that particular orbit, the simple condition that has to be satisfied is, right, the circumference of that particular orbit, that is 2 pi Rn, should be equal to an integral multiple of wavelength n times lambda. Okay, this is what he told. How can we proceed from here? He told 2 pi Rn is equal to n times lambda. ठीक है, and n times lambda का formula is h by p, 2 pi Rn. ठीक है, now n, h P is equal to momentum mass into velocity, that is equal to 2 pi Rn. Okay. Now rearranging MVR, M and V I'm taking it to the left hand side. MVR is equal to NH divided by 2 pi. And what is MVR? Angular momentum L. So L का value मिल गया NH by 2 pi, and thus de Broglie was able to prove the second postulate of Bohr. Done? Hi Sudeep. There was small change of time with the class for today. Matlab for the rest of this month we'll be having a class in the afternoon. Matlab during the afternoon time. I don't know how many of you will be able to join because you'll be having schools, and schools are started nowadays. So I don't know how many of you are going to be there. So anyway, if anyone is missing the live classes, you all can watch the replay and the recorded one. Okay, time will be at 2 p.m., 2 o'clock. Okay, so let's see, do we have any questions left to be done here? Yes, no questions, we all can do that. Good, good, good. Question kar le. What's the answer for this? जल्दी फटाफट. Okay, I'll explain. I'm not able to get the answer from anyone. Let's see. The orbital speed of the electron in the ground state of hydrogen is V. What will be its orbital speed when it is excited to another orbit which is having an energy of minus 3.4? Let's get it done. First tell me what is the general formula of electron in the nth orbit. Formula is given by Z divided by N into some constant value. Let's call it as V0. Okay, what is given first statement? Orbital speed of the electron in the ground state. Okay, in the first state V1 is given as V. So that is equal to Z of hydrogen atom is 1, nth orbit is 1, and V0. Matlab in the initial case V ka value equal to V0. Question is what is the value of speed when it jumps to an orbit with minus 3.4 electron volt energy? Okay. For that we need the formula for energy. Formula is energy of nth orbit is equal to minus 13.6 divided by n square. What is the energy given here? Minus 3.4 is equal to minus 13.6 by n square. So n square का value हो जाएगा 13.6 by 3.4, which is 4. N का value हो जाएगा 2. मतलब it is jumping to the second orbit. So if it is jumping to the second orbit, okay, speed of the second orbit V2 is equal to, formula is Z by N into V0. Z is same, hydrogen 1, N is second, V0. V0 का value equal to V है, so V by 2 is equal to the speed of the electron in the second orbit. मिल गया तो मिल गया, ऐसे ही मिल गया. देख ले कितना सही है, कितना सिंपल है. Yes, बढ़िया. Mistake. No worries. I'll give you one more question. Try to do that without having any mistakes. Here it goes. Anyone? Answer? ऑप्शन बी बोल रहा है सुदीप. लेट्स सी विच वन इज करेक्ट. राइट. ओके. क्वेश्चन क्या है? हाईएस्ट एमिशन वेवलेंथ. Right, so among all the 4 transitions given here in the options, we are asked to find out that electronic transition which will be giving the maximum value of wavelength. Okay. Now, maximum value of wavelength emitted. Right, tell me what is the basic condition for any photon or wavelength to be emitted. It should be moving from a higher energy level orbit to lower energy level orbit. Right, so in the first case is moving from 1 to 2. मतलब low to higher, here the emission is not happening, absorption is happening. Similarly, when it moves from 2 to 5 also, it is moving from lower to higher, so energy is absorbed, not emitted. So in the case of option B, it is moving from 2 to 1, and in the second case it is moving from 5 to 2. Fine. So it is in both the case of B and D, the electron is moving from higher energy orbit to lower energy orbit, so obviously energy is being emitted. ठीक है. Energy is being emitted in the option B and D. Question is to find out during the emission which emission produces largest wavelength. देख ले. Energy का formula क्या है बच्चा लोग? H into frequency. Frequency is C by lambda. Now here you can see that the wavelength emitted will be maximum when energy is minimum. Okay, because they are inversely proportional to each other, right? Okay, now let's see. So instead of finding that emission with maximum wavelength, we can find out the one with minimum energy. Okay, this is the first orbit, this is the second orbit, third orbit, fourth orbit and fifth orbit. Tell me what is the energy of first orbit? Minus 13.6. First orbit. Second orbit में minus 13.6 by 2 square, that is minus 3.4. Third, fourth, fifth पे minus 13.6 divided by 5 square. ठीक है. One of the transition is मेरा बच्चा लोग when it moves from 2 to 1. When it moves from 2 to 1, energy how much will it be? अरे the difference in energy between the minus 3.4 and minus 13 points का difference कितना है? 10.2. Now the other is moving from 2 to 5, sorry 5 to 2, 5 to 2 ऐसे. अरे 13.6 by 5 square is very nanu munnu value. So the difference between nanu munnu value and the energy of second orbit, which is 3.4, will be almost 3.4 around. Now look into the figure and tell me which energy transition has a larger amount of energy emitted. From 2 to 1, which one has a lesser amount of energy transmitted when it moves from 5 to 2. ठीक है. So from 5 to 2, when the transition happens, lesser energy is being transmitted. देख ले, when lesser energy is being transmitted, maximum energy is associated, wavelength is associated with it. अब समझ में आ गया? अब समझ में आ गया मेरे बच्चा लोग? Why the answer is option D here. Sudeep, is the concept clear to you? Right? ठीक है, बढ़िया बात है, बढ़िया बात है. Fine. So let's move on. That was the last question, and here successfully we have completed the chapter of atoms. Okay, and nanu munu chapter था, nothing more. Now देख ले, if you want to grab some scholarship for when you join colleges, the best plan is to be a part of an Unacademy Prodigy scholarship test. An exam is going to happen on Feb 13 from 12 to 1 p.m. completely for free. You can enroll with the code of AMB10 and be a part of this for free. देख ले, first rank MacBook मिल जाएगा, 2 and 3 ranks Apple iPhone. So what all amazing things you're going to get it. These are the courses for class 11th. These are the courses for the class 12th. ठीक है. Special class timetable here we have, and you can see that free special class features also is what we are having it over here, as you all can see, amazing features now. Thank you so much everyone for being here and making the class so awesome. Those who haven't subscribed, you can subscribe to the channel, like the class and share it with all your friends. Okay, so thank you so much everyone once again. Bye bye Sudeep, Angel and everyone here in this class.